Okay, in this video, we're going to take a look at solving a system of inequalities. Now, if you remember what a system was, it's two or more equations, which is what we looked at before, but now we're going to look at two or more inequalities with the same variables. If you watched our previous video on graphing an inequality on a coordinate plane, that's going to be very helpful. If you have not done that, I would suggest going to look at that video first and then coming back to graphing a system of inequalities. So let's take a look. This is a review of last class solved by graphing. So go ahead and pause the video and graph these and we'll see how you did. Okay, go ahead and check and see. You should have graphs similar to this one. So we've got y is less than 2/3 x minus 1. We graph the y-intercept, the slope. We use a dashed line because it is only less than, not less than or equal to. And then we shade below the line. You can pick a test point. If you plug in a test point to this equation and it's true, that's the side you would shade. So for example, if we chose 0, 0 for this one and plugged it in, that would be a false statement and we would not shade that side. Y greater than or equal to -3 along the y-axis, we plot -3, solid line because it says less than, greater than or equal to, and then we look to see where are the numbers on the y-axis greater than or equal to -3, and they are above, so we shaded there. Our last inequality, x is greater than 1. Plot 1 on the x-axis and draw a line through it. This one is dashed because it's just greater than, not greater than or equal to. And all the numbers that are greater than 1 are going to be to the right. If you can do this, then you can graph a system of inequalities. So if we're going to go ahead and graph a system, we would graph all of these equations in the same space and then go ahead and shade the appropriate regions. And that will give us all the possible solutions. A system of linear inequalities in two variables is when we have two or more linear inequalities with the same variables. Solutions to the system are ordered pairs that fit with both inequalities. A graph of a system of linear inequalities is a graph that's showing all the solutions. So we will see lots of shaded areas, and those shaded areas show all possible solutions. First thing we're going to do is graph each inequality, find its intersection, and that would be the solution. The intersection is going to be the overlapping area of shaded space. So let's take a look at our first example and we'll work it together. I'm going to graph this first one in light blue. So I've got +2, my y-intercept, and my slope is 1/2. I rise up 1 over 2, up 1 and over 2, down 1 and to the left. There we go. It's a less than symbol, so I'm going to use just dashed, not solid here. Arrows on either side. And I can decide on my shading. I'm going to use 0, 0 as my test point. So when I plug it in, 0 less than 1/2, 0 plus 2, I get 0 is less than 0 plus 2, 0 is less than 2. That's true. So that means that 0, 0 is a possible solution. So I'm going to go ahead and shade right now. Below that line, just a light shade if you're doing this with your pencil. Don't darken it too much because that might not be our final solution. Okay, then we're going to go ahead and take a look at our second inequality. I'm going to graph this one in pink. My y-intercept is at 5, which is here. And then my slope is -2, so I'm going to drop down 2 and to the right. Down and to the right. And keep going. All right, this one is greater than or equal to. So I need a solid line for this. And again, I'm going to pick a test point so I know which side of the pink line to shade. I'm going to choose that 0, 0 again because it's just out in space. So 0, 0 is my test point, and it could be a different test point for both lines. You don't have to pick the same test point. I love choosing 0, 0. It just makes the math a little more simplified. 0 greater than or equal to 0 plus 5. So let's see, is 0 greater than or equal to 5? Is that true? No, that's false. 0 is not greater than or equal to 5. That means I don't want to shade the side of the pink line that has 0, 0. I want to shade the other side. So I'm going to go ahead and take my highlighter and shade the other side. So that's going to be over here. Now, how do I know what my solution is? Take a look, and it's really helpful with these colors, or if you shade in opposite directions. Where do you see my pink and my blue shading overlap? Where is that overlapping section? Yeah, it's right here, right in here. So what I want to do after I've shaded everything and I found my point of intersection is to just darken that area in. Darken in the final area. You could even, if you're using a colored marker, you could pick up another color and darken in that final color. You could also choose to erase the areas that you don't want shaded for your final answer. You could also, if you want to be super clear, draw an arrow and say, this is my final answer. And that final answer means that any ordered pair that's found in this super dark shaded area is going to work. It will be a solution to both of my equations. So at the end, if I'm not super confident in my shading, I can always pick a point in that shaded area, plug it into both, and make sure it's a true statement for both inequalities. And that's how you graph a system. Let's try another. This one has 3 statements. We might want to do 3 colors, or I'll show you how to graph each one separately and then erase what's not needed. So I've got y is less than or equal to 5, so up here on the y-axis at 5, and it's going to be a solid line going across that axis, and all the values that are less than 5 are below that line. So I'm going to lightly shade here, boom. Next one, I'm going to graph that one in pink. X is less than 4. So along the x-axis, I go over to 4. 1, 2, 3, 4. And this is less than, so I'm going to need a dashed line. And the side that's less than 4 is going to be over here to the left. So instead of shading above the blue line, because I know my answer has to be below the blue line, I'm only going to, oops, I did an eraser instead. Sorry about that. I'm only going to shade over here. And I can even take my eraser and go ahead and unshade on this side of my pink dashed line, because that's not going to be part of my final solution. And I can see where I kind of erased a little bit of my pink line. So I'm going to go ahead and darken that in a little bit. Make sure that your boundary lines are really noted on here, because whether your boundary lines are solid or dashed, that's part of your final solution. It's not just the shading. It's that dashed and solid that also makes a big deal. I'm going to go ahead and pick orange for my last line and graph this one. So I'm up here at 2 on my y-intercept. I know it's getting a little crazy with all the colors. And then we're going to drop down 2 and go to the right 1. Down 2 into the right 1. Down 2 into the right 1. Down 2 to the right 1, maybe about here. And go in the opposite direction as well, so maybe about there. This is a greater than or equal to, so I know that's going to be a solid line. I'm going to go ahead and graph that solid line. Make sure you have arrows on either side of your line. Make sure it's super solid. You need to thicken it in or darken it in, that's good. And now we need to figure out, okay, y is greater than or equal to. So when I look at my orange line, here's my dot along the y-axis. All the points that are greater than that are going to be above that, and that's where I see here in my shading. So I can pick a test point, I can pick 0, 0, or I can pick something else, but my final shaded area is going to be over here. Now I know it has to be lower than the blue line, and I know it has to be to the left of the pink line. So I'm just going to shade in there, and then I'm going to take my eraser and erase all of these other colors that are not part of my solution. Now with this tool, I don't know that I'm actually going to get all my dots cleared off and definitely on the other side of that orange line, but you get the picture. You want to do the best you can. And there you have it. There's our final solution. Any ordered pair within that wedge is going to be an answer to my inequality. All right, I'm going to go ahead and ask you to graph the next few. And we might want to go ahead and change a few things on here. I see some numbers that aren't going to be on your graphing. So if you want to go ahead and modify these with me as well, that way you can really get a picture on your graph. Let's say this is 3x minus, let's say 3. So I'm going to make this a 3 here. And that way it'll appear on my graph. Over here it says y is less than 8. Let's make that 4. All the rest will be visible on your graph, so go ahead and take a moment, pause the video, graph them, and then check, see how you did. If you went ahead and modified your inequalities like I have, your graph should look very similar to mine. So for A, we've got a dashed orange line, we've got a solid red line, and then we've got shading in between that red and orange line at the bottom of our graph. For letter B, we had to graph 3 different inequalities, and we get this kind of trapezoidal shape for the shaded region. And letter C, you'll see that dark shaded purple area is what we have for our final solution. Now remember what this means. This means you can pick any ordered pair you want in that dark shaded region, and you should be able to plug it in for all of your inequalities, and it will give you true statements for all. So that's one way that you can always check to make sure you're doing your systems correctly. Systems of linear inequalities are 2 or more linear inequalities with the same variables. The graph of a system of linear inequalities is the intersection of the half planes of the solutions of all the inequalities in the system and represents the solutions common to all the inequalities. To create a graph of a system of linear inequalities, we graph each inequality in the system, shading the appropriate half planes for each inequality. The intersection of the shadings is the solution for the entire system. So you're looking for that overlapping shaded area to decide or define that system solution.